A centrifugal pump is a mechanical artifact that converts kinetic energy into pressure energy in order to move fluids such as water, solvents, light oils, and chemicals through a system. The main component is the impeller, which is a rotating disc with lots of blades. The impeller rotates, forcing the fluid out of its blades due to a centrifugal force. Other main components include the casing, which surrounds the impeller and controls the flow of the liquid, the horizontal shaft, the bearings, and the bearing cover. The artifact is used for everything from supplying clean water in towns to handling tough jobs like moving slurries or corrosive chemicals in factories. Factors like temperature, pressure, and the type of fluid they pump will make a difference.
Material selection and justification. Materials for centrifugal pumps are selected as per ASME and ISO standards based on fluid type, temperature, and pressure. Stainless steel and bronze are used for impellers, cast iron or stainless steel for casings, high-strength stainless steel for shafts, graphite or ceramic for seals and bearings, ensuring durability, corrosion, resistance, and performance. Stainless steel for corrosion resistance and strength in harsh environments for impellers, cast iron for cost effectiveness and durability for casings, high-strength stainless steel to handle stress and wear for shafts, finally graphite and ceramic for wear resistance and low friction. Justification for required tolerance and surface integrity. The plan of centrifugal pump components requires resilience and surface wraps up to guarantee product execution and toughness. Impeller or exact resilience within the impeller's edge plan is to basic to guarantee reliable steam and to diminish turbulence. A smooth surface wrap up makes a difference, minimize vitality misfortune due to grinding, moving forward pump effectiveness. Volute casting, tight resistance between the casing and the impellers decrease backflow and increment weight maintenance. Fundamental for pump proficiency. A smooth surface wraps up within the casing helps in lessening wear from liquid development and encourage making stride solidness. Shaft and orientation. High precision machining is required to preserve shaft arrangement and diminish vibration. The bearing surfaces need a fine wrap up to play down grinding and permit smooth operation, basic for dragging out the life expectancy of the pump. Measures just like the American Society of Mechanical Engineers ASME B46 for surface unpleasantness and resilience are regularly connected in pump fabricating to guarantee components reliability.
I will now talk about the manufacturing processes. Firstly, sand casting will be used to make the volute casing. A pattern replicating the casing will be fitted in the sand to create the mold. Then the molten metal will be poured into the cavity through the gate. Once the metal is solidified, the sand can be shaken off the part, then any excess bits will be removed and the part will be heat treated. Investment casting will be used for the closed impeller. This process is better for smaller, more intricate shapes than sand casting. A pattern for an injection mold is made via CAD for the wax to be poured into. This is then dipped into the ceramic slurry and once hardened, the wax is melted out to reveal the final mold for the metal to be poured into. The lathe machine will use facing, turning, and boring tools to create the wear ring, and then a blade to separate the part from the material. Pump packing is used to seal pumps, and are often made from braided fibrous materials like graphite, acrylic, or others. The fibers will be spun and treated to create the needed graphite fibrous material. Then they will be braided together to create the packing. For the CNC turning, the shaft's required diameter, length, and special features will be programmed via CAD and inputted into the CNC lathe, generating a toolpath. The workpiece will be clamped in the chuck and the turning operations such as facing, turning, boring, and threading may be used. For die casting, a two-part die will be designed and molten metal will be injected at high pressure and cooled inside the die, then ejected using the ejector pins. Die casting is a great process because you can reuse the mold as its two parts clamp together. The metal cast gives it a good surface finish and there is minimal material wastage. Casting and machining will create scrap material, which is often discarded and is bad for the environment. Finding ways to reuse or recycle this material can help ease the issue. Manufacturing processes require a noteworthy use of energy, which can contribute to carbon outflows when non-renewable energy sources like coal, gas, or oil are used. There are many reasons why this is damaging the environment, such as climate change and greenhouse gases. Thank you for listening. I hope you've learned something about the centrifugal pump.